solution algorithm using pseudocode, then flowchart, then a simple demonstration using Java programming language. So program design, we are looking at 3 different components: input, then process, and then output. So think about you are using calculator. So if you add 3 numbers, let's say 10, 20, 30, you can press 3 inputs with the electronic calculator. Then you may use operator like a plus symbol. Then you may press equal sign to see output. So we are looking at the example here now. So we have 3 given inputs, 10, 20, 30. The process, we are using operator between operand 10, 20, and then between 20 to 30. And then we are using equal signs to say that 10 plus 20 plus 30 output shows up as 60, or result of operations show up as 60. Okay, now just think about it. So we have 3 numbers, and then 10, 20, 30. Then we use operator. The answer is 60. Computers often use locations, or what we call as memory locations. We can declare, or we can reverse the memory location using variables like A or B or C. And in each variable we can allocate a number. For example, A equal to 10, it means A refers to number 10, B refers to number 20, C refers to number 30. And once we have that memory location, we can use operator A plus B plus C. Then again, output is refers to 60. Sometimes we can use another variable to get the answer. Say sum equal to A plus B plus C. Then instead of 60, we can use the variable name sum. So if you print sum, it will give you answer 60, which is exactly the same. So if you look at your right hand side, more likely computer program, then left hand side, it seems very straightforward. But main idea is if you have a problem statements like add 3 numbers, you should be able to identify what are the inputs and what's going to be output, so that you may be able to get process. So let me summarize a few things here. Operator, addition, subtraction, the third one is division, last one is multiplication. The main idea is look at your keyboards. Okay, we are using plus, minus, divisions, and then multiplication on your number key. We also have operands between operator. Something like we can use actual numbers, or we can use symbols, or I call it ABC. Locate to refers to memory locations. We call it as a variable. We can use ABC, or we can use more meaningful name, like a number for the first input. I may say number underscore 1. So number underscore 1. Then second number or second input, I may say on number underscore 2, 20, number underscore 3 equal to 30. Then we say sum equal to number 1 plus number 2 plus number 3. Again, main idea is you should be able to identify 3 inputs. You can name it whichever you want. Usually main idea is try to use something more meaningful, like number 1, number 2, number 3. We can replace the 3 numbers. Next topic is pseudocode. This is one of the techniques to present solution algorithms using simple English sentence like. Okay, so let me explain what is algorithm here. Again, the algorithm is steps that represent, well, steps we can describe as a set of instructions that can be performed to solve the problem. So in our case, as 3 numbers, there might be 3 steps at least. So something to do with input, then process, then output. So let me try to explain instructions to be performed. In certain order, okay? Usually in sequential order. So, and there might be some repetition as well. And sometimes we have to go through some conditions. Let me just simplify here. So what I'm going to do is, let me use the same problem statement and then present a solution algorithm using pseudocode. So that this pseudocode can be translated into any specific computer programming language. You can consider as a general computer program that can be used for any specific programming language. Okay, and I will name the program as 3 numbers. I will use underscore instead of space for this program name. For algorithms, I will focus on 3 components. Input as a lead number 1, 2, 3, or you can say lead 3 numbers. I prefer to say number 1, 2, 3. If it's possible, we should be able to specify instead of using general sentences. So I will use a specific sentence here. For input, say sum equal to number 1 plus number 2 plus number 3. Or obviously you can say calculate sum, which is not very specific, so I prefer to do this way. The last one is print sum for output. Then like to say end or end of the program. Okay, next topic I'm going to cover flowcharts. That's another technique to present a solution algorithm visually. I'm going to use a program called Dia, which is open source, for drawing diagrams. So this is how it looks like. Okay, so I'm going to present solution algorithm visually this time. Okay, let me just write it down what it is. It's a form of visual representation of the solution algorithm. Okay, I think that was typo. Okay. Again, this is a visual representation. Okay, there are certain symbols you should get familiar with it. Again, let me just show you how to download. Okay, you can go to About and then you can click here. It's a Dia 0.97.2. That's the newest version. Okay, I'm using Windows 10, so I'm going to use Windows version. I will click Window. It's a quite small program. Okay, free download 20 megabytes. Straightforward, download it and double click. Follow the instruction. Straightforward installation anyway. I have already installed it, so I will skip through installation process. So there are a few things you need to know. Okay, the first thing you need to know is terminal interrupt, which is what I call as a start and then end. You just present the start and then input, process, and output. Again, we are going to focus on very basics. Okay, I'm going to drag and drop another one, and as you can see, we have a program called add three numbers. We just indicated that's the beginning and this is the end. And I'm going to focus on three components. Again, input, then dealing with the A equal to 10, B equal to 20, and then sorry. So we are going to use input and output. It uses same symbol, or we can represent same with the same symbol. So that's the output. So I'm going to use the same symbol again. One for input. Usually idea is top to bottom. Okay, that's the process, A plus B plus C. We need a special symbol for process. Okay, looks like a rectangle, that's the process. So read, you can type pseudocode. Okay, very simple English sentence. Read number 1, number 2, number 3. You can put it in one sentence, or you can say read number 1, read number 2, number 3. You can use 3 sentences. I prefer to use one sentence here. And then let me enlarge it so that I can actually see clearly with this in the box. Okay, from now on, I may need to move around all these shapes and then fill in the gap. So it's going to take for a while. Okay, please be patient. Because it's not about using tools, it's about get familiar with processing input and outputs. And then while you are drawing pictures, you have a clear idea what's going to be here, what's going to be next, so that it will help you to develop algorithms. And focus on output. Okay. Okay. The last part is we need to show some sort of a sequence flows. Okay, using arrows. Again, top to bottom. So I'm going to use arrow to present, not that one. I will use the simple arrow. Okay. Present the flow from top to bottom. And I will continue. I think pretty much that's all. Okay. If you look at here, we have the flowcharts. I think there was a typo, so I fixed it. Okay, there was number underscore 2. And then you can zoom, enlarge it if you want to. Usually I do that. I think I should do that at the beginning. Okay. So we know that program design, for example, problem statement with add 3 numbers as an example. And we have the 3 components, input, process, and output. Then we have to deal with multiple operator. And we also talk about operands between operator. Operands usually represent as a variable like A, B, C that stands for numbers, or we can say stands for certain values like numeric values here like 10, 20, 30. Okay, we also have different techniques to present the solution algorithm using pseudocode. What we call it as a structured English-like sentence to present programming structure or program techniques. Okay, we have a problem statement, same example. Start with the program name and present the input, and then we present the process. We also present output. Then we make sure we end program. Then we are talking about flowchart. So that's another technique to visualize solution algorithms. For flowcharts, we had special symbols. Then last one is, again, the process is there. Some number 1, number 2, number 3. And then we want to make sure that program ends. Okay. Okay, next step, I'm going to cover actual coding into a specific programming language. I may use Java programming language. So idea is once we have a problem solutions using pseudocode or flowcharts, and easily translate to a specific programming language. So we focus on the first one. Okay, has 3 numbers. We name our program. Java has specific name called class, or every Java program has at least one program called class. So we use S3 numbers without space. That's the Java programming language convention for class name. You can consider this a program name. And then within program, we start with the curly brackets. We can consider last one as an end. Last curly bracket as an end, if you look at your flowchart. And then double slash means it's actually comments. It's a part of a program, but it does not recognize as instructions. Okay, the comments may be useful for you or for me. So just try to explain what it is. That's all. Then every program needs to have at least one main methods. It means that your program needs to say which instruction has to start with. So we create a main. Okay, don't worry about the syntax at the moment. We just saying we have a main methods or operations. That's the starting point of your program. Now here we can add 3 components: input, process, and then output. Okay. Again, the double slash means single line comments. Okay. So I'll put the comments, process, and then output. This might be a good idea at the beginning if you are not familiar with the programming language. So let me declare 3 inputs. Integer data type called int in Java. Variable name number 1, basically saying memory locations assigned with the 10 default value. I will do number 2 after number 1. Okay, so say integer value is stored into variable called number 1. Okay, I will put in 2 lines. So that will be a lot easy to read. Okay. Okay, let me declare a second variable called number2 so that we can store number 20. And then I will create another variable called number 3 with default value. Sorry. Okay, up this point we declare 3 inputs in Java programming language. So now we focus on next one. We will focus on process. Okay, just look at the flowcharts. So process has one statement, sum. It's almost identical, but again, the convention is when you say number 1 plus number 2, number 3, every statement in Java programming, you have to end with a semicolon. Again, after you calculate it, you may like to save it to another memory location called sum. Before that, you need to declare locations, memory locations. So int sum, and then we can assign the calculation using assignments equal sign. So answer 60 will be stored to sum, or I can say sum refers to 60. Now we focus on output. Java has a specific syntax called system, part of the system dealing with output device out, and then method name called print. And then we can put it inside the parentheses. Can say system.out.print. That's the end of the program. Okay, if you want to use Java, that's what I'm going to cover next few weeks. And then you can save it. Okay. So I copy. Save it as add 3 numbers.java. File extension is Java. Again, your file name should be same as your class name. Again, okay. So once you save your source code, again, all source code should be compiled into machine code. This is the syntax in Java. Okay, Java C stands for Java compiler. Then you can type the name of the source code, add 3 numbers.java. Let me explain here in written form so that you can read it later on. Okay. Then you can run your Java program using Java, and then name of your program with the extension. Okay, let me explain here again. Machine code in Java we call it a bytecode. It can be ejected by Java commands. Then output may appear on your console, or you can say your monitor. Okay, once you learn it, you should be able to 60. Okay, now let me quickly demonstrate for you. Okay, let me go through one by one before I demonstrate. So I put number one, when you have a problem statement, you come up with input processor output components. As a part of the program design, you may need to use operators. Then you may have operands like A, B, C. And then it depends on how you declare. You can say A, B, C or number 1, 2, 3. And then you may use it between operator as an operand. And as a solution algorithm, we use the pseudocode to present a solution algorithm. Okay, solution algorithm was presented with pseudocode. We also present the solution algorithm with the flowcharts, as you can see left-hand side. Then we code solution algorithm into specific programming language, in this case Java programming language. So here is the source code. Okay. So let me copy and save it as S3 numbers.java. Compile it, run it. So then let me quickly demonstrate for you. Okay, save it new. I'll put it C drive on the Java directory. With the command line, I will say, okay, let me change the directory. It's on the Java. So here is the program, source code. Java C add 3 numbers to Java. Again, compile source code into machine code. Then you can load your program. Here is the output 60. Again, the idea was not teach you how to do Java programming at this point. Quickly demonstrate how the solution algorithm can be translated into specific programming language like a Java programming language. So if you